video, we are going to do hypothesis testing with proportions. So here we have the example that we had before about our health systems, and they claim that 87% of their employees got a flu shot. So this is the claim of 87%. So remember we said that P equals 0.87. And the sample actually said that out of the 300, 249 received their flu shot. And we're testing at a level of significance of 0.01. So we usually call that alpha equals 0.01. So we already did the null and alternative here, but we'll go over that again. So remember, the null is always equals about our parameter, so P equals 0.87. And our alternative is going to be P equals, P does not equal 0.87. And remember, because we have the not equal sign, this is a two-tailed test, because we can look for both sides of our normal curve. So we'll start off with the critical value approach. This one is more time consuming, so I would recommend you do the p-value approach if you're using StatCrunch, but I will go over both methods to start off here. So we have our normal curve, and we have our 0.87 in the middle. And we want to see if this 249 out of 300 is going to be in our rejection region or not. So 249 over 300, which we found before, is 0.83. So we want to see if the 0.83 will be in our rejection region. So here we have our curve, and we want to figure out what this rejection region is going to be. Because it's two-tailed, it's going to be on both sides. And this alpha is going to tell us how much area is in each of these. So because we have two tails, we need to divide this by 2, which will give us 0.005. So there's going to be 0.005 in this side and 0.005 in this side. So we want to figure out what these z values are that are going to be on this curve. So if we go into our calculators, in our normal one, we remember how to find our critical values. So our critical value, we want to put in our area over here. So remember, we want to find 0.005, I'm going to compute, and we get negative 2.58. So down here is going to be negative 2.58. And up here will be positive 2.58. And what we're going to do is we're going to calculate our test statistic. You can do that by hand, but we are going to do that in StatCrunch. So to do that, we're going to go into Stat, and this is a proportion, so we're going to do proportion stats, and it's one sample with our summary. So you can see our number of successes was 249. Our total number of observations was 300, and that's from our p hat here. And we're going to find our hypothesis test for 0.87. So you can see it puts the p there for you. This one's not equal, so we're going to leave it at that. And this should line up with your hypothesis test that we wrote down in the beginning. So once you have all that typed in, you can hit compute. And you can see it makes the sample proportion, which we found here. And then it gives us our z statistic. So we can say that our z statistic will be negative 2.06, so it'll be about there. So this was our rejection region. And the 2.06 was not in that rejection region. So because it's not in rejection region, we fail to reject. So we fail to reject the null. Remember, we never accept the null, we just fail to reject it. And putting this in real words, fail to rejecting the null, this means we do not have evidence so we don't have evidence to reject the claim to reject the claim that we set up here. So we don't have evidence to reject their claim that 87% of employees got the flu shot. So that could be true. We don't have any evidence against it. We can't say it is true because, again, we can never accept a null, but we just can say that there's not evidence against it to reject the claim. And then when you're writing this, make sure to actually write down the claim. So you would say to reject the claim of, and then you would write that sentence above. I'm not going to write it here to save time, but you get the idea. So then we're going to do the p-value approach, and you'll just do the same steps in StatCrunch, but this time we're going to look at the p-value. So I'm going to draw out the same curve that we had before. And this time I'm going to label the 0.005 in both ends. We got a p-value of 0.0394. Now that is greater than our alpha, which was 0.01. So when p is greater than alpha, we fail to reject the null. And then we would come up with the same conclusion as we did before. So we fail to reject the null, which means we do not have evidence against the claim that 87% of their employees get a flu shot every year. So that is how you find both of these in StatCrunch, doing it with both approaches. Both of these approaches will always agree, so you only have to do one. I think the p-value approach is easier because all you have to do is compare the p-value to your alpha level, which we found up here. For the critical value approach, you had to first figure out what the z was and then compare your value that you found. So remember to always first figure out what your claim is, then write down your null and alternative hypothesis, draw out your curve, and then once you have your curve, you can go into StatCrunch, do your proportion stats, and compare your p-value to the alpha. If p is greater than alpha, you fail to reject. If p is less than alpha, you reject. And then that is how you do hypothesis testing for our proportions.